Here's problem 3, all about finding the x-intercepts of a parabola or quadratic equation by either factoring or quadratic formula. And according to the directions, you have to factor if it's possible to factor. If it's not possible, then you go and proceed on to the quadratic formula. So we're going to go through each problem one by one, and when I tell you to pause, pause and work ahead of me. So to start this problem, go ahead and fill out a diamond on your own. Welcome back. In case you had trouble with this, here's a quick review. To get the top number of the diamond, you multiply the first term, which in this case is 1 is the first coefficient. Multiply that to the last term, which is -6, and 1 times -6 is -6. For the bottom of the diamond, it's the middle term, which in this case counts as negative. Since there's -1x, it's -1, just the number in front of x is the number. So multiply in this case, it would be like 3 times -7 would be -21 on top, and on the bottom would be 5, for example. All right, continuing. Now to factor this thing, we want two numbers that multiply to -6 and add to -1. Let's make the list. What multiplies to 6? Well, it could be 1 times 6, or it can be 2 times 3. Those are the only possibilities with integers. Now to get a -6, one of these numbers has to be negative. I'm not sure which one. So let's say the 1 was negative. We want to make sure that even though we have -1 times 6 does equal -6, this combination should add up to the bottom number. But -1 plus 6 doesn't add to -1. So let's try switching the sign around. That'd be positive and negative. That still multiplies to -6, but if you add 1 plus -6, you get -5, not -1. So this combination is not going to work for us. It's got to be the 2 and 3, obviously, since 3 minus 2 is 1, but still. To get -1, it will have to be a -3 and then a +2, because a +2 times -3 does equal -6, but +2 plus -3 would equal -1. So our combination for the left and right hand sides of the diamond are 2 and -3, and now we can set up our rectangle based on that information. So I would pause and set the rectangle up yourself, then come back. Here's my work. Remember, the first term always goes in the top left box. -6, the last term, goes in the lower right. The purpose of the rectangle is to fill in the other inside boxes. In our case, we have 2x is one corner, and -3x is the other corner. And from there, we're trying to fill out the sides of the diamond, or the rectangle. And to get x squared, it has to be x times x. That's the only way to get x squared that makes any sense for factoring. To get -3x, we already have an x. We just need to multiply by -3 more. That way, x times -3 equals -3x. Down here, we have x times something equals 2x. We already have the x. We just need a 2. So +2 will work, because +2 times x equals 2x. And automatically, this box works because -3 times 2 equals -6. So let's take our problem, and now we have the factored form of this would be y equals, instead of x squared minus x minus 6, we have equals x minus 3 times the quantity x plus 2 from this side. Cool, done. Now look back at the problem. We're not done with the entire problem. All we've done is factored. Now we have to actually find the x-intercepts, or the roots, or the zeros. There's 3 different words for the same thing. X-intercepts is the most common, but zeros and roots are other words for the x-intercepts. Remember, to find x-intercepts, you put 0 for y, and then you solve for x. So I put 0 for y, it still equals x minus 3 times x plus 2. And now we have to apply the zero product property to figure out, to get 0, what could x equal? In this case, the problem's easy enough to just do mentally. To get 0, you could have 3 minus 3 is 0, and 0 times anything would be 0. So one possibility is x equals 3. On this side, you could have negative 2 plus 2 is 0. So x equals negative 2 is another possible solution because negative 2 times anything else would be 0. So those are two possible solutions, but written as x-intercepts, it would be 3 comma 0 is the official answer, or negative 2 comma 0. Negative 2 comma 0. This is the official way to write an x-intercept, since x-intercepts are locations. They're not just numbers, they're places on a graph. So there's that. All right, problem 2. Pause the video, set up a diamond and a rectangle, and try to factor this yourself. Go for it. Welcome back. So here's my diamond so far. Here are all the combinations to get 21, except that to get negative 21, one number has to be negative. But if you try all the combinations, let's say within the one's negative. 21 minus 1 is not 5. And if you reverse the signs and make this negative, that just gives you negative 20. But it's still not 5. So this combination is not a possibility. But even the 3 and 7, 7 minus 3 is 4, not 5. So this combination is not going to work no matter what. So since this problem is not factorable, we can't use factoring. We have to use the quadratic formula, which will always work. So pause and write down just what's the equation of the quadratic formula. Make sure you know it. Write that down. So here's the quadratic formula. I hope that you got it right. For the test, you'll need to memorize it. And you can go to YouTube, which you're here already probably, and just search quadratic formula. You'll find a bazillion songs. People are having fun with it. But the classic one we sang in class was the Pop Goes the Weasel song, which was x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And Dima from third period recorded it on his phone. You can ask him. He may be able to paste it on his Facebook page or MySpace, whatever it is. But go to YouTube. There's a bazillion videos on that thing. All right. So for us, the reason I put parentheses here is because this is the number one area students mess up on the quadratic formula. Put parentheses everywhere, and you won't mess up the negatives as often. So for us, our a value is 3, since 3 is the coefficient of the x squared term. Our b value is positive 5, since that's the x coefficient. And negative 7 is the constant term that has no variable with it. That's our c value. There we go. Now let's go ahead and plug these into the quadratic formula. Do this on your own. Press pause and do it on your own, then come back. All right, let's check your work. So negative b value plus or minus b squared minus 4 times the a value times the c value. And notice how I just put blank parentheses. Please do that. I promise you it'll save you a lot of grief that you're unaware of otherwise. So there we go. Now let's simplify this thing. Press pause, do it yourself, and come back. Time to check your work. Here's mine. So I've plugged in, simplified. 5 squared is 25. Now for this part, I would do the sign separate from the numbers. Just a negative times a positive times a negative. That is 2 negatives. So it's going to be positive something. Then for the number part, 4 times 3 is 12, and 12 times 7 is 84. So separate the sign from the number. That's probably the best way to do that. Then add 25 and 84 is 109. And now you find out that 109 doesn't square root nicely. You know, a square root of 100 would be 10, but 109 has no perfect square that equals 109. So you've got to use a calculator. Take a calculator, do a square root of 109, and you'll find that the square root is about 10.4. So I'm going to put 10.4 here. And on this part of the test, it's cool if you use a calculator, not a problem, because 109 doesn't square it nicely. So there's 2 possible answers here to our equation. Either it's negative 5 plus 10.4, all divided by 6, or it's negative 5 minus the square root of 109, which is 10.4 divided by 6. And since using a calculator, from this point forward, just take a calculator, do negative 5 plus 10.4, divide that by 6, and you're going to get about 0.9. Just round to the tenths place, that's good enough. So there's one possible answer. And second answer, negative 5 minus 10.4 is negative 15.4, divided by 6, and you get negative 2.6, rounded to the tenths place. So there's the 2 x-intercepts for problem B. out of space for this video, so I'll do problem C and D on the next video.